Hello everybody. Today we have to discuss about 25 questions related to the chapter Motion in a Plane, the third chapter in the class 11 textbook. We will start with the first question. The first question is related to vectors. Here there are two vectors. One is A, which is equal to 2i plus 3j. And there is another vector B, that is B equals I plus j. We have to calculate the component of vector A along the direction of B. For this, we may use a relation. Component of A along the direction of B is given by vector A dot vector B. We have to calculate the component of A along B. For this, we may write the equation as vector A dot vector B divided by modulus of vector B. That is A dot B divided by modulus of vector B. That is, we may solve like this: 2i plus 3j dot, we have I plus j divided by modulus of vector B. That means root of modulus of I is 1 and the modulus of j is 1. Root of 1 square plus 1 square. We know that I dot I equals 1. J dot j equals 1. While I dot j equals 0, j dot I equals 0, and like that. Hence, the solution is 2 into I dot I, that means 2, plus 3 into j dot j, it is 3, divided by root of 1 plus 1, root 2. That is, the answer will be 5 by root 2. So, here the correct answer is option A, 5 by root 2. The second question, a particle is projected making an angle 60 degree with the horizontal with K amount of kinetic energy. The kinetic energy of the particle at the highest point is, here the angle of projection is 60 degree and is a projectile. For a projectile, we may draw like this: it is a projectile. The velocity of projection is V0. Hence, the initial kinetic energy K equals half m V0 square. This is the initial kinetic energy. We have to calculate the kinetic energy at the highest point. At the highest position, the velocity will be like this. It is V0 cos theta. It is a projectile. You know that for a projectile, the horizontal velocity remains constant. That is, horizontal motion is with a uniform velocity, while the vertical motion is with the uniform acceleration. Hence, the vertical velocity may change. Here we want only the horizontal velocity. The angle of projection is theta equals 60 degree. This is given in the question. Angle of projection is 60 degree. Hence, kinetic energy at the highest point, I may represent as K1, kinetic energy at this point. It is half m V0 cos theta square. Here theta equal to 60 degree, so that it is half m V0 into cos 60 the whole square. Cos 60 is 1 by 2, that is half m V0 square into 1 by 2 square. It is 1 by 4. But this half m V0 square is K. The initial kinetic energy is K into 1 by 4. Hence, the correct answer is option C. It is K by 4. Question number 3. Which quantity of projectile remains unchanged? അപ്പോൾ ഒരു പ്രൊജക്റ്റൈൽ കേസാണ് നമ്മൾ പറഞ്ഞിരിക്കുന്നതെന്ന് മനസ്സിലായി കാണും. അപ്പോൾ ഒരു പ്രൊജക്റ്റൈലിന് ഏത് ക്വാണ്ടിറ്റിയാണ് അൺചേഞ്ച്ഡ് എന്നാണ് ക്വസ്റ്റ്യൻ. അപ്പോൾ വി മേ കൺസിഡർ എ പ്രൊജക്റ്റൈൽ ഹാവിംഗ് ഇനിഷ്യൽ വെലോസിറ്റി V0. In the above question, I have mentioned that horizontal motion is with the uniform velocity always. Horizontal velocity is V0 cos theta remains unchanged always. Hence, the quantity which remains unchanged in projectile is horizontal component of velocity. Since horizontal motion is with the uniform velocity. Here the vertical motion is the uniform acceleration, but here we mention only the horizontal component. Hence, the vertical component of velocity may change. It is moving with the uniform acceleration. Kinetic energy may change, momentum may change, but the horizontal component of velocity will remain constant. Hence, the correct answer is option D, horizontal component of velocity. Then question number 4. Which one of the following is the correct expression for the centripetal acceleration? Here the options are 4 pi nu square r square, 4 pi square nu square by r, 2 pi nu r and 2 pi nu by r. We know that the centripetal acceleration is given by A equals v square by r. But we know that v equals r omega. Then the relation may be A equals r square omega square by r, or maybe r omega square. This is the relation for centripetal acceleration, and this is the relation for centripetal acceleration. ഇങ്ങനത്തെ ഒരു ഓപ്ഷൻ ഇതിലില്ല. Hence the correct answer is to be modified like this: omega equals 2 pi nu. There is another relation. Hence it may be modified like this: A equals r into 2 pi nu the whole square. On expanding we will get 4 pi square nu square r. This is also centripetal acceleration. Hence centripetal acceleration may be A equal to v square by r. Centripetal acceleration may be A equal to r omega square. It may also be A equal to 4 pi square nu square r. Hence the correct answer is option A. Now there is question number 5. This is another type, assertion reason type question. Assertion is given as when a 30 dyne force is inclined to y-axis at 60 degree, then vertical and horizontal component of force are 15 dyne and 15 root 3 dyne respectively. That's the assertion. As a reason is said that when a vector A is inclined to y-axis at an angle theta, vertical and horizontal components are A cos theta and A sin theta. The reason is correct. If it is inclined at an angle theta with the y-axis, I may represent it like this. A vector may be represented like this. This is a vector F at an angle 60 degree with the y-axis. Then the y component is to be F cos 60 and the horizontal component is to be A sin 60. Here angle is 60 degree. F cos 60 means F into 1 by 2. F sin 60 means F into root 3 by 2. That is, the vertical component will be F cos 60, it is F by 2, and the horizontal component will be F sin 60, F into root 3 by 2. Here F is given as 30. 30 into 1 by 2 is 15. Here 30 into root 3 by 2 means 15 root 3. It is given that the vertical component is F cos 60. We got it as F cos 60 equal to 15. Hence the vertical component is 15 dyne and the horizontal component is 15 root 3 dyne. Hence the answer is option A. Both assertion and reason are correct and the reason is the correct explanation. Now question number 6. This is also an assertion reason type question. Here it is given that the assertion is a projectile is projected at an angle theta and then at an angle of 90 minus theta. Keeping the velocity same. In both cases, the range will be same. The assertion is true, since there is a condition that if theta 1 plus theta 2 equal to 90 degree, then it will have the same range. That is, there are two angles of theta and 90 minus theta to have the same range. We have proof for that by using the relation r equal to v0 square sin 2 theta by g. Also we can show that r equal to v0 square sin 2 into 90 minus theta by g, and that will get v0 square into sin 180 minus 2 theta by g, and this will be also give v0 square into sin 2 theta by g. That is, range will be same for angles of theta and 90 minus theta. Hence, the assertion is right. But for this, the equation for range is to be V0 square sine 2 theta by g. But in the reason it is given that the reason is R equal to V0 square sine theta by g. Here, if it is V0 square sine 2 theta by g, it was correct. Hence, here the assertion is true, but the reason is false. Hence, the correct answer is to be option C. Assertion is true, but the reason is false. Now, it is an assertion reason type question. Question number 7 is also an assertion reason type question. Here it is mentioned about uniform circular motion. Here in the assertion it is given that for uniform circular motion, the displacement and acceleration are directed towards the center along the radius, but it is wrong. And the reason given is that centripetal acceleration is represented as A equal to omega square by R. It is also wrong. That is, we have during this uniform circular motion, the displacement may be like this. It is tangential. And the acceleration may be directed towards the center. Here it is wrong, since it is given that both displacement and acceleration are along the radius towards the center, but it is displacement is along the tangent, while the acceleration is towards the center. Hence, the assertion is wrong. And the centripetal acceleration is given by omega square, A equal to R omega square. It is given that A equal to omega square by R. Hence, this is wrong. This is the right relation. Hence, this is wrong. And the definition given is also wrong. Displacement and acceleration are directed towards the center. Along the radius, it is also wrong. Hence, the answer is option D. Both assertion and reason are false. Answer is option D. Now, question number 8. The angle between the vectors of vector A equal to I plus j and vector B equal to I minus j. Angle between the vectors. We may simply calculate the angle between the vectors like this. We know that I is the unit vector, j is the unit vector, which are mutually perpendicular to each other. Minus j is the vector opposite to it. Since I and j are having equal magnitude, the angle I plus j will make an angle of 45 degree. Similarly, I minus j will make an angle of 45 degree. Hence, the angle between I and j is to be 90 degree. But we may use some mathematical method also. We have cos theta equals A dot B divided by modulus of A into modulus of B. This is a mathematical method of finding the angle between the two vectors. That is, here it is I plus j dot I minus j divided by modulus of A root of 1 square plus 1 square. Modulus of B root of 1 square plus minus 1 square. We know that I dot I is 1, j dot j is 1 divided by root 2 into root 2, that is 0 by 2 equal to 0. Since cos theta equal to 0, theta equals 90 degree. Here also, the angle between I plus j and I minus j is 90 degree. It is simply a general method, and here is the mathematical method. Anyhow, the angle between the two vectors of A equal to I plus j and B equal to I minus j is 90 degree, hence the correct answer is option C. Now, question number 9. Which of the following pairs of vectors are parallel? 4 options are given. I may represent like this. We have the D option. I may represent. We have A equals I minus 5j and B equals 2I minus 10j, which are parallel. I may represent B as 2 into, 2 may be taken as the common factor, I minus 5j. That means I minus 5j is A. That is this 2A. If vector A can be represented like this, then vector 2A can be represented like this with a double the length. Then only they are parallel. This same condition cannot be applied to A, B or C. Hence, the correct answer is option D. That is, the two vectors A and B are parallel in option D. Now there is question 10. There are two vectors given by vector A equals I plus 2j plus 2k, and another one B equals 3I plus 6j plus 2k. Then we have another vector C have the same magnitude of B but the same direction as that of A. Then magnitude is to be calculated as root of A square plus B square, like that. That is, we may calculate same magnitude of B. That is, magnitude of B is root of, here B is 3I plus 6j plus 2k, root of 3 square plus 6 square plus 2 square. That is magnitude of B. Then direction of A, that is unit vector of A, vector divided by modulus of it, that is called the direction. Unit vector will give its direction. Vector A is given by I plus 2j plus 2k, divided by its modulus is given by root of 1 square plus 2 square plus 2 square. And then we may write magnitude of B is root of 9 plus 36 plus 4, it will be root of 49, it will be 7. And the direction is I plus 2j plus 2k divided by root of 4 plus 4, 8 plus 1, 9. That is I plus 2j plus 2k divided by 3. Hence, magnitude is 7, direction is I plus 2j plus 2k divided by 3. That is 7 by 3 into I plus 2j plus 2k. That is having the same magnitude, but same magnitude as that of B. B യുടെ magnitude, same magnitude as B എന്ന് പറയുമ്പോൾ the magnitude is 7. And the direction of A means unit vector of A. Hence, the correct answer is to be option A, 7 by 3 into I plus 2j plus 2k. The next question is question number 11. A certain vector in the xy plane has x component of 12 meter and the y component of 8 meter. It is then rotated in the xy plane so that the x component is halved. Then its new y component is, that is, the x component is 12 and y component is 8. Now the magnitude is root of x square plus y square, root of 12 square plus 8 square, root of 144 plus 64. It will give root of 208. That means x square plus y square equals 208. In the next part, it is rotated so that x component is halved. That is, x component becomes half the original. Then root of x square plus the remaining y component may be y1 square. X component is halved to x by 2. Now x by 2 square plus y1 square. Magnitude is to remain unchanged. Root of 108. The same magnitude will give, only vector is rotated. That is, on squaring we will get x square by 4 plus y1 square equals 208. X is already given 12. That is 12 square by 4 plus y1 square equals 208. That is y1 square equals 208 minus 144 by 4. That is, we will get 208 minus 36. Okay, we will get 172. That is y1 square equals 172, y1 equals root of 172. You know that 13 square is 169. That is, here it is somewhat greater than 169. Hence, the correct answer to be somewhat 13 point something. The correct answer is 13.11. The correct answer is option B. Next question is question number 12. X and y components of a force F acting at 30 degree to the x-axis respectively. Here 30 degree with the x-axis, then the x and y components. So we may represent a vector at 30 degree to x-axis. Vector may be f. Now here this component is f cos 30, horizontal component. The vertical component is f sin 30. Now x component will be f cos 30 means f into root 3 by 2. The x component is root 3 by 2f and the y component is f sin 30, that is f into 1 by 2. The y component, vertical component is f by 2. Correct answer is option C. Next question is question number 13. It is given that if the magnitude of the sum of the two vectors is equal to the magnitude of the difference between the two vectors, then what is the angle between these two vectors? I may represent two vectors like this, vector A and vector B. Vector A and vector B has a magnitude of root of A square plus B square plus 2AB cos theta. And magnitude of the difference between the vectors is root of A square plus B square minus 2AB cos theta. It is given that these two magnitudes are equal. That is root of A square plus B square plus 2AB cos theta equals root of A square plus B square minus 2AB cos theta. On squaring we will get A square plus B square plus 2AB cos theta equals A square plus B square minus 2AB cos theta. A square cancels, B square also cancels. When it is shifted here, the value becomes 4AB cos theta equals 0. That means cos theta equals 0. If cos theta equals 0, theta equals 90 degree. Hence, the correct answer is option D. The angle is 90 degree. Next is question number 14. A particle is thrown at an angle of 45 degree with the horizontal. Angle of projection is 45 degree. If it remains in air for 1 second, what was the initial velocity? It is projected at 45 degree, remains in air for 1 second. Remains in air is called the time of flight. When it reaches the maximum height, it is called the time to reach maximum height, and returns back and it is called time of flight. Hence the given quantity is time of flight. It is 1 second. That is how much it remains in air. We have time of flight is given by 2 V0 sin theta by g. This is the relation for time of flight and is given as 1 second. Also given that theta equals 45 degree and we may take g as 9.8. Then we may write like this, 2 into, it is V0 into sin 45 divided by 9.8 equals 1. How much is V0? V0 equals 9.8 divided by 2 into V0 equals 9.8 divided by 2 into sin 45. That is 9.8 divided by 2 into sin 45 is 1 by root 2. That is, we may write 9.8 divided by root 2. The value of root 2 is 1.414. And here on dividing we will get the option is to be option B, 9.8 by 1.414 is to be 6.93. This is the apt option. The correct answer is option B. Next is question number 15. A simple question related to projectile motion. The angle between the velocity and acceleration of the highest point of a particle projected upwards at an angle of 30 degree with the horizontal. It is simply the angle between velocity and acceleration. If it is projected like this, for any angle of projection, it is angle of projection is 30 degree. The velocity is like this. The velocity is v0 cos theta. For any projectile, if it is projected, then it will remain as a freely falling body. For any freely falling body, acceleration is 9.8, it will be directed towards the center of the earth. Hence, the angle between velocity and acceleration is to be 90 degree. It is independent of the angle of projection. Hence, the correct answer is option C. For any angle of projection, angle between velocity and acceleration, the highest point is 90 degree. Next question is question number 16. The horizontal range is 4 times the maximum height. Then the angle of projection is, it is given that horizontal range is 4 times the maximum height. We know that horizontal range R equals V0 square sine 2 theta by G. This is the maximum height. Horizontal range. And the maximum height is V0 square sine square theta by 2G. In the question it is given that horizontal range is 4 times the maximum height. That is R equals 4 times H. Here R is V0 square sine 2 theta by G. And it is equal to 4 into V0 square sine square theta by 2G. Here V0 square cancels, G cancels, and the remaining 2 and 2 cancels. Sine 2 theta, it will be 2 sine theta cos theta. Here 4 and 2 cancels, giving 2. That is 2 sine square theta. Here also a sine theta cancels, 2 cancels, and the remaining is cos theta equals sine theta. Cos theta equal to sine theta is only for 45 degree. As you know, theta equal to 45 degree. Since sine 45 is 1 by root 2 and cos 45 is 1 by root 2. Otherwise, you may write tan theta equal to 1 or theta equals 45 degree. There is only one angle, sin theta equal to cos theta, only when theta equal to 45, or when tan theta equal to 1, then theta equal to 45. Hence, the correct answer is option C. Next, question number 17. It is given that an arrow is projected into air. Its time of flight is 5 seconds and range is 200 meter. What is the maximum height reached by it, taking G equal to 10? It is given that the time of flight is 5 seconds and range is 200 meter. Time of flight T equals V0 sin theta by G as 5 seconds. From this I may write V0 sin theta by G equals 5 by 2. Another data is given, R equal to V0 square sin 2 theta by G is equal to 200 meter. It may remain there. We have to calculate maximum height. Maximum height is V0 square sin square theta by 2G. This is the relation for maximum height. That is, I may represent like this, G into G by 2 into V0 square sin square theta by G square. That is, it is given by G by 2 into V0 sin theta by G the whole square. It may be written like this. We may write like this, G by 2 into, when G is multiplied and divided to get like this term. Then G by 2, G is given as 10. It is 10 by 2. Then we have the relation V0 sin theta by G is 5 by 2. And we may put the value 5 by 2 square. Remaining will be 10 into 25 divided by 2 into 4. It will be 8. That is 250 by 8. And we will get the value as 31.25 meter. Here another data is also given as R equal to 200. Here it is not used. Here the correct answer is A equal to 31.25 meter. Answer is option A. Now there is question number 18. the range of a projectile when launched at an angle of 15 degree with the horizontal is 150 meter. What is the angle of projection when launched at 45 degree to the horizontal? When launched at 15 degree with the horizontal is 150 meter. So the range of a projectile R equals V0 square sine 2 theta by G. When theta equal to 15 degree, range is 150 meter. 15 degree, the range is 150 meter. That means R at 15 degree. V0 square sine 2 into 15 divided by G equals 150. That is V0 square into sine 30 by G equals 150. You know sine 30 is 1 by 2. V0 square by 2G equals 150. Am I right like this? V0 square by G equals 150 into 2 equal to 300. Then we have a question. How much will be the range if projected at 45 degree? As you know, the maximum range is at 45 degree. That is V0 square sine 2 into 45 by G. That is R maximum equals V0 square by G. Here, from this data we have V0 square by G is equal to 300. Hence, R maximum equals 300. Hence, the correct answer is option B. The maximum range is 300 meter. Now, question number 19. The horizontal range and maximum height of a projectile are equal. Horizontal range and maximum height are equal. Then, the angle of projection is, horizontal range and maximum height are equal. Range and maximum height, okay. R equals V0 square sine 2 theta by G. Maximum height V0 square sine square theta by 2G. These are equal. And then V0 square cancels, G cancels, and the remaining will be sine 2 theta equals sine square theta by 2. Sine 2 theta means 2 sine theta cos theta equals sine square theta by 2. Here a sine theta cancels and the remaining will be 4 cos theta equals sine theta. And then we will get tan theta, sine theta by cos theta or tan theta. Sine theta by cos theta equals 4. Tan theta equals 4. Hence theta is to be tan inverse 4. Hence the correct answer is to be option B. The answer is tan inverse 4. Next question is question number 20. The speed of a projectile at its maximum height is half its initial speed. Then the angle of projection is speed of a projectile at its maximum height. That is, there is a projectile at the maximum height. There's only horizontal component of velocity as V0 cos theta. The vertical component of velocity is 0 and the initial speed is V0. The initial speed is V0 and V0 cos theta equals speed at the maximum height is half the initial speed, V0 by 2. This is a question. Then we have cos theta equals 1 by 2. Cos theta equal to 1 by 2 means theta equals 60 degree. Hence the angle of projection is to be 60 degree. That is, the correct answer is option A, 60 degree. Next is question number 21. An object is projected so that horizontal range R is maximum. You know that R is maximum means theta equal to 45 degree. If the maximum height of object is h, then the ratio of R by h. Maximum range means theta equal to 45. How much is R by h? R at 45 degree, it is V0 square sine 2 theta 2 into 45 divided by g. That means V0 square by g, since sine 90 equals 1. H at 45 degree. H is given by V0 square sine square theta by 2g. That means V0 square sine square 45 divided by 2g. As you know, sine 45 is 1 by root 2, V0 square by 2. That is by 4. Sine square 45 is 1 by 2 and the remaining 2, V0 square by 4g. How much is R by H? R is V0 square by g and H is 4g by V0 square. The remaining is 4. That is R by H equals 4, or R is to H means 4 is to 1. The ratio is 4 is to 1. Answer is option A, 4 is to 1. Next is question number 22. It is a direct question. A projectile is projected with a speed of 49 meter per second at an angle of 30 degree with the horizontal. That is, initial speed V0 49 and theta equal to 30 degree. Time taken by the projectile to reach the highest point, not time of flight. Time taken to reach the highest point up to this time, it is t. Time is given by t equals V0 sine theta by g. Here V0 is initial velocity, it is 49 velocity of projection, and sine, the angle of projection is 30 degree, divided by g, it is 9.8. You know, sine 30 equal to 1 by 2, that is 49 by 9.8 into 2. 49 by 9.8, it is 5. 5 by 2 equals 2.5. Hence, the answer is to be 2.5 seconds. Correct answer is option B, 2.5 seconds. Next is question number 23. A ball is projected horizontally with a velocity of 5 meter per second from the top of a building 19.6 meter high. How long will the ball take to hit the ground? It is projected. That means it is a projectile. Any projectile is a freely falling body. Hence, we may use the equation S equals V0t plus half AT square. Here, time taken to reach the ground, S equals half into GT square. That is T equals root of 2S by G. Time to reach the ground. Here it is projected horizontally with a velocity. We may consider only the vertical velocity. Vertical velocity is 0. Horizontally with a velocity 5 meter per second. If so, we may consider only the vertical motion. For vertical motion, initial velocity is 0. That is why I have taken like this, and A equal to G for free fall. And now it is root of 2 into 19.6 divided by 9.8. Horizontal velocity is 5. You consider only vertical motion, vertical velocity, initial vertical velocity is 0. The remaining will be root of 2 into 2 equal to 2 seconds. We will cancelling 2. The correct answer is option B. Answer is 2 seconds. Next question is question number 24. The ratio of the angular speed of a second hand to the hour hand of a watch is. A second hand will complete one rotation in 60 seconds. And the hour hand will complete one rotation in 12 hours. We have angular velocity is given by theta by t. For one complete rotation, angle is 2 pi and the time taken is called time period t. Angular velocity of the second hand to the hour hand. The ratio is to be determined. The ratio for a second hand, the angular velocity is to be 2 pi divided by 60 seconds. For the hour hand, the angular velocity is given by 2 pi divided by 12 hours. That is, this will be converted to seconds. 2 pi divided by 12 hours. 1 hour is 60 minutes and then 60 seconds. how much will be the ratio of the angular velocity of the second hand to the angular velocity of the other hand? Here it is 2 pi divided by 60. The remaining will be 12 into 60 into 60 divided by 2 pi. That's the ratio of the angular velocity of the second hand to the angular velocity of the other hand. Now 2 pi cancels, 60 cancels, and the remaining will be 12 into 60 is 720. Ratio of the angular velocity of the second hand to the other hand is 720 is to 1. Here the correct answer is option C, 720 is to 1. Next is question number 25. Which one of the following statements is not correct in uniform circular motion? Option A, the speed of the particle remains constant. Uniform circular means it is moving with a uniform speed along a circular path. Then only it is called a uniform circular motion. And this is right. Next, the acceleration is always points towards the center. And this is called centripetal acceleration. Acceleration is directed towards the center, as I mentioned earlier. Option C is angular speed remains constant. For uniform circular motion, the angular speed must be a constant. And the option D is the velocity remains constant. But it is wrong, since for uniform circular motion, radius is same, speed is same, radius is same, speed is same, but the direction will change from point to point. That is, the velocity will not remain constant. Velocity will change because of the change in direction. Hence, the correct answer is option D, the velocity remains constant. Now, we have discussed about 25 questions related to the chapter motion in a plane. We can study it repeatedly with a better practice and with a similar type questions so that you can score well in the examinations. Okay, thank you.